Okay, so hello everyone. In this video, we're going to discuss the concept of center of mass. Okay? Now, center of mass, in the simplest terms, this refers to the balancing point. Okay? Okay, now, ang pinakamadaling way to visualize this is if we have a seesaw. Tapos, let's say, nandito yung pinaka uh, balancing point. And then, if we have two objects or two people here na may different masses, tapos we take the distance or we take their distance with respect to the balancing point, na ito yung kanyang center of mass. Now, of course, kung dalawang tao yan, they can readjust their position or they can exert external force, no, para mabalance nila yung seesaw, or ang point naman ng seesaw is they want to go up and down. Now, if these are fixed objects, ibig sabihin hindi sila makakagalaw on their own, ang pwede natin gawin is yung kanyang balancing point, ito yung i-adjust natin. So, yun yung goal natin for this topic, yung center of mass. Hanapin natin balancing point ng isang system of objects along a line or a plane. Okay? We also define what we call the moment. The moment, this is technically the mass times the distance from the axis of rotation. Okay, we have the following notations for our discussion. We will denote x bar as the center of mass, m, m sub 0 as the moment, or as the total moment, m as the total mass, and in terms of the moment and the mass, the center of mass is given by the moment over the mass. Okay. Now, the center of mass, this is where the fulcrum should be placed in order for the system to be balanced. Now, our goal is to find the center of mass given a configuration or a system of objects. Okay, the moment here, as mentioned above, it's actually the mass times the distance, no? So we're going to be solving it using this summation of the product of m sub I, x sub I, wherein m sub I, this denotes the mass of the ith object, and x sub I, this denotes the distance of ith object. This one is relative or from the origin. And of course, the total mass, this is given by the sum of all individual masses. So in terms of the summations, the center of mass is given by the summation of m sub I, x sub I, all over the summation of m sub I. Okay, let's consider this example. Suppose we have four masses which are placed on a number line as follows. We have that the first mass measures 12 kilograms placed 4 meters to the left of 0. The second mass has 12 kilograms placed 4 meters to the right of 0. The third has 30 kilograms placed 2 meters to the right of 0. And the last one weighs 6 kilograms placed 6 meters to the left of 0. So of course, it will be very helpful for us to sketch an illustration that will show this scenario. I suppose we have a number line. Let's say nandito yung 0. Tapos, increments of 2 naman ang distances natin. So, pwede natin gamiting scale yun. We have 2, 4, 6, 8, 10, -2, -4, -6, -8. By the way, by convention, yung to the right of 0, positive. Yung to the left ay negative. Okay, so, let us draw this scenario. Yung first mass daw natin ay located 4 meters to the left of 0. So, nandito siya. Okay? Ang mass niya ay 12 kilograms. Yung second object natin, 4 meters to the right of 0, having mass equal to 12 kilograms as well. Yung third object natin, 2 meters to the right. Ang mass naman nito ay 30 kilograms. And lastly, we have an object 6 meters to the left of 0, having a mass of 6 kilograms. So, ganito yung ating scenario. And then, we proceed by getting the center of mass. No? The total moment, it's again given by the summation of m sub I, x sub I. Clearly stated dito yung mga m sub i's. Yung x sub I, ilagay lang natin. This one will be -4. This one will be 4. This one is 2. And the last one is -6. Okay? So if we solve this summation, we will be getting 12 times -4 plus 12 times 4 plus 30 times 2 plus 6 times -6. Simplifying, these two will cancel out. Tapos we have 60 minus 36 or 24. Tapos our mass is equal to the sum of all the individual masses. So this is 12 plus 12 plus 30 plus 6, or we have 60. So the center of mass will be given by the moment over the mass, or 24 over 60, or 2/5. Take note that the center of mass refers to the location. So ang ating unit of measure will be in terms of distance, no? Now, since meters yung ginamit na unit of measure, gagamitin natin unit of measure ay meters din. Tapos, since this is positive, ang ibig sabihin nito na yung center of mass ay 2/5 meter to the right of 0. Okay, so in order to balance this system, yung center of mass natin should be somewhere here. Oh. Okay? Now, pwede natin rin kasi isipin na dito sa configuration na 'to, yung total heavier objects ay nasa kanan ng zero compared dito sa nasa kaliwa. So, we can expect na yung center of mass should be nearer this side having heavier mass. Okay, now we can also extend this to the two-dimensional space, no? Yung previous na kinonsider natin was center of mass of objects on a line. Yung ngayon naman, i-extend natin to the xy plane or the two-dimensional space. So, katulad dun sa um, katulad sa Cartesian plane, any point on a two-dimensional space can be denoted as xy. Okay? So, yung center of mass natin will have two numbers as well or two coordinates. So, the center of mass will now be denoted by x bar, y bar. Okay? And then we also will have what we call the moment about the x-axis and the moment about the y-axis. The mass is still the same, so this would still be the sum of all individual masses. But this time, we're going to analyze what it means when we say moment about the x-axis and moment about the y-axis. Now, to recall, again, ang moment is mass times distance, no? So, ibig sabihin, yung moment about the x-axis, this would be the mass times distance from x-axis. Likewise, ang moment about the y-axis, this should be the mass times the distance from the y-axis. Now, i-analyze natin, no, how we will write the formulas for this one. So, suppose we have a Cartesian plane. Tapos, meron tayong point dito with coordinates xy. Ito yung distance from the y-axis. And this is the distance from the x-axis. Now, if we analyze the points or this point, yung x dito, yung x coordinate will technically give us the distance of a point from y-axis. Tapos yung y naman, this is distance from x-axis. Okay? So, para mas clear, ito yung x-coordinate. Ito yung ibig sabihin ng x-coordinate. Tapos, ito naman yung y-coordinate. So, ibig sabihin, if we want to get the moment about the x-axis, this would be the mass of the object times its distance from the x-axis, which is given by its y-coordinate. Tapos, kukunin natin yung sum ng lahat ng to. Okay? So, yung moment about the x-axis will be something like this. And using the same argument, yung moment about the y-axis will be the sum of all products of the mass times the distance from the y-axis. Okay? So in turn, our center of mass will be denoted by x bar, y bar, or moment about the y-axis all over its total mass, moment about the x-axis all over its total mass. Okay, so let's consider this example. Suppose we have 3-point masses placed in the xy plane as follows. So the first one will have a mass of 2 kilograms at negative 1, 3. The second one has 6 kilograms at 1, 1. And the last one has 4 kilograms at 2, negative 2. Okay, pwede tayo mag-drawing na illustration. So, drawing natin yung illustration that will describe this scenario. Okay, M1 is at negative 1, 3. So, this one is M1. M2 is at 1, 1. And M3 is at 2, negative 2. Okay, yung mass ng M1 ay 2 kilos, yung M2 ay 6 kilos, and yung M3 ay 4 kilos. So if we want to find the center of mass of this system, we need to find the total mass, the moment about the x-axis, and the moment about the y-axis. Okay, so for the total mass, madali lang, kunin lang natin yung sum ng lahat ng mass. So this will give us 12. Okay, for the moment about the x-axis, take note, ang formula natin for the moment about the x-axis will be the product of the mass and the y-coordinate. So in this case, yung ating first one, adjust ko lang to. Yung ating first one has a mass of 2 kilos and yung y-coordinate niya ay 3. Second one, 6 kilos, y-coordinate is 1. And third one is 4 kilos, y-coordinate is negative 2. So simplifying, we have 12 plus 6. So 18 minus, sorry, but 12. We have 6 plus 6. So we have 12 minus 8, or that is 4. And the moment about the y-axis is given by the summation of m sub I, x sub I, which when written down will be 2 times negative 1 plus 6 times 1 plus 4 times 2. So simplifying this, we have negative 2 plus 6 plus 8, or that is equal to 12. Therefore, the center of mass is given by x bar, y bar. This is the moment about the y-axis all over m, moment about the x-axis all over m. So we have here 12 over 12, 4 over 12, or 1, 1/3. So the center of mass of this configuration will be found somewhere here. Somewhere dyan. Center of mass.